Hi, today we are learning about complex algebra and phasors. Um, and when we talk about complex algebra and phasors, we have to know three different forms really: rectangular, polar, and sinusoidal. Um, and rectangular and sinusoidal are pretty straightforward. Polar can be called two different things, polar or phasor. And all you really need to know is that they're derived differently. Um, it's the same form. It's this is polar form, the red here. It's the same form whether you call it polar or phasor. It's just derived differently, and so those words are interchangeable. But the basic of complex algebra, the most basic thing you need to know is that I is the square root of -1. Obviously, that hurts calculators' feelings. You can't square root a negative number, and so that's how we can talk about complex algebra because of this. We define I as the square root of -1, and in engineering, I is typically used as current, and so we changed it to J. Okay, so J is the square root of -1. And so that's kind of the basic definition, the fundamental principle for this topic. And so what we're going to do today is move stuff around. We're gonna figure out how to simplify this into one thing by adding, subtracting, and multiplying and dividing. And so the two tips that you want to make sure you know, right, are right here. They're listed right here. When you're adding or subtracting, do it in rectangular form, and when you're multiplying or dividing, do it in polar form or phasor form. And so not only are we going to add and subtract these forms and multiply and divide these forms, but we're also going to convert these forms to different things. And so these right here are those conversion factors. This is going from polar to rectangular, and this is going from rectangular to polar. These are the equations that you use to manipulate that around. And this is kind of just like the definition of a sinusoidal. And I'll do that first, actually. I'm going to do number 3 first, just to get out of the way. So essentially, what we're going to do is just, whenever you see a sinusoidal, we have to move it around. You convert it to polar, and then you move it around from there. And so we're going to convert that sinusoidal over there on number 3 to polar first, just like this. We're going to, this 50 is going to be the magnitude of our polar form, and this angle is going to be the angle of our polar form. That's all it is. So that's your answer. That's how you convert from sinusoidal to polar. It's that easy. Once you have it in polar, you can manipulate it around. And the one thing that I want to point out So when we're talking about sinusoidals, you want to be careful with what you compare to what. In this case, this is a cosine graph, okay? And so if we wanted to convert this whole thing to a sine wave, everything stays the same except this part right here. You add 90 to it. Okay? You add 90 to the angle to convert from cosine to sine. And so sometimes that's helpful because when you compare multiple sinusoidals, Like let's say you have a completely different sinusoidal that you want to work with this one. Not only do the frequencies, the omegas, have to be the same. This is omega. Not only does that have to be the same in both of the graphs, but the trig does as well. And so that's an easy way to convert something to the same trig. If one of them's cosine, it needs to be sine, you can just add 90 to theta. But if this were the case, right, if we were converting this to polar form, we'd have 50 for the magnitude, and the angle would be 125 instead. And so that's just, it's pretty simple. I mean, it's not, converting from sinusoidal to polar isn't terrible. But these can get tricky. So we're going to convert this polar form to rectangular form. Okay, so this right here, this is our A, and this right here is our theta. And so when this is our equation to go from polar to rectangular, and so what the math is set up as is cosine Okay, so what I did here, this is A, this is theta, plug them into this equation, pretty straightforward. This is the equation, and it calculates out to be 6 plus J9. And so this is the not real part, and this is the real part of the rectangular form. And for number 2, we're going to convert that rectangular form, right, that I have written up there on number 2, to polar form or phasor form. Okay, so number 2 here, this equation right here is this same equation right here, and so this is A. This first term is A, the real part. The not real part is B, and in this case they're interchangeable, they're the same number, but in this part of the equation, it doesn't matter which is which, but in this part of the equation, you have to have the real part on the denominator. And so when you plug it all in, this is what you get. And so the reason why we're learning this, how to convert all these numbers, all these types of all the rectangular, polar, and sinusoidal conversions, the reason why we're learning all that is because when we add and subtract and multiply and divide, we want to be in the right form to make it easier on ourselves. So we're going to do that right here. I'm going to do a big problem. So as you can see, this is polar, rectangular, polar, rectangular, rectangular. And so the first thing we want to do is convert this right here to rectangular. And so what you're going to, right, this is polar to rectangular. Okay, so I converted this polar form to rectangular form right here, 1 plus J2. And so now I have all these 4 terms in rectangular form, which is where I add and subtract. And so this is all addition in here. The numerator and the denominator are addition. And so I'm going to add those together. So I'm going to copy this down. Okay, so it's pretty simple adding rectangular forms. When you add them, it's just going to be the real part plus the real part, and the fake part plus the fake part. And so the real part plus the real part is 4 in this case. Fake part plus the fake part is 0 in this case. 7 minus 3, 6 minus 2 is 4. And so now it's division. Right? Now we have two rectangular forms and we're divided. So we're going to convert it to polar form so we can do that. Sorry about the lights. So what I did here was I took this rectangular form and this rectangular form, converted to polar form. Right, you can check them out later. And so when dividing polar form, okay, you're going to divide the magnitudes and you're going to subtract the thetas. Okay, so this is going to equal out to. I'm just going to leave that 4, 0 in front right here. I'm not going to do anything with it yet. But I am going to divide these. So 4 divided by 5.66 is 0.707. Okay? And 0 minus 45 is negative 45. Okay? That's division. That's how you divide polar forms. You divide the magnitudes and subtract the angles. And so multiplication, very similar. Again, we want it to be in polar form, and we have it both in polar form, except instead of dividing and subtracting, we're going to multiply and add. Okay? So 4 times 0.707 is 2.828. 2.828, and we're going to add these 2 degrees, okay? 0 plus negative 45 is negative 45, right? And so this is our answer here. This is our final answer. That's what this is all equal to, except this might bother you. This negative 45, it might bother you. What it is here's, that's really bad. Don't be afraid of that negative sign. It's here's a polar graph, okay? So the magnitude is how long this line is, whatever line we have, and the degree is where it's located. And so since it's negative, instead of starting from the positive x-axis and going counterclockwise, we're going to go clockwise. We're going to go backwards, 45 degrees. And so our line is right here. Right? Negative 45 degrees. This is 45 degrees right there. And so in order to have a positive number, all you gotta do, add 360. That would make the same exact line, right? Except it's a positive value. We could add as many 360s as we wanted, but just to get rid of the negative, all you have to do is add 360 once. And so if you didn't like the negative, it'd be the same magnitude, angle 315. Okay, these are the same things. Those two answers are the same, and they're both the right ones. So that's all.